Hi to all. Today's topic is current electricity continuation, that is Wheatstone bridge we are going to discuss. Then what is Wheatstone bridge? It's an arrangement of four resistors. It's an arrangement of four resistors in the shape of bridge. Look at here, there are four resistors P, Q, R, S are the resistances of four resistors. These four resistors are arranged in particular manner to measure one of unknown resistance out of the four resistances. And now what is the some condition we will use to measure the unknown resistance? The condition is that when current through the galvanometer is 0, then P by Q equal to R by S. What is this? Look at here, this is a four resistances P, Q, R, S are the four resistances, and this is galvanometer. And when the current through the galvanometer is 0, right? This is the current through the galvanometer that I am taking as I suffix G. This when the current through the galvanometer is 0, this galvanometer shows the 0 deflection. At that moment the P by Q is equal to R by S. This is called as balancing condition of Wheatstone bridge. Then if the current through the galvanometer is 0, then we write if Ig is 0, that means current through galvanometer is 0, then the P by Q equal to R by S. That means the ratio of these two resistances P by Q, that is equal to the ratio between these two resistances, that is R by S. This is the balancing condition. Now let us see in this what are the various terms that we are using. Here P, Q, R, S are the four resistances, G is the resistance of the galvanometer, and one battery we are using it here. The battery supplies the current, and from this the positive terminal, from the positive terminal current will starts, and that is I current is coming it here. From the positive terminal of battery I current enters, and this will come to this point. After coming to this point, this point we will take as A. After coming to this point, the current will split. How much current is coming at here? That is I current is entering. After coming to this point, the current will be split. This side some current and this side some current will goes. And this side I1 and this side is I2. I will split into I1 and I2. Then, and this point I will take as B. And now this side I1, I current comes and this will splits. That is, it will become I1 and I2. This side I1 goes, this side I2 goes. Then I1 current enters to this point B. After coming to this point B, the I1 again it will splits, because there are two ways are there. Some current goes this side and some current goes this side. The I1 is coming here, it will split as I3 and IG. Some current I3 this will goes this side and IG will goes this side. And this side Ig is coming and this side I2 is coming, and these two currents will be combined and goes this side as I4. And now this side I3 is coming and this side I4 coming, and that two will be combined and it will goes outside, right, like I. That means in the external circuit the current is I. Look at here, the current is I. Now I will take the terms, and this is A, B, this is C, and this is D. This is D. And now we have to prove this balancing condition of Wheatstone bridge. It was very simple and it was very important. Its applications are very important, and this is also very important, right? And now let us see how to prove this. For that, what we have to do and to prove the balancing condition. Now we have to take the two loops set here. We have to apply the Kirchhoff laws, and for that, according to Kirchhoff's first law, what you know, according to Kirchhoff's first law, we know already Kirchhoff laws. Kirchhoff's first law, that is junction law. According to the Kirchhoff first law, what you know, that is at point B I will apply. At point B, yes, when you apply at point B, what you will get? For point B, entering current equal to leaving current. Point B is a junction, I am applying for the junction. Point B entering current is this side I1, current I will comes, this will splits as I1 and I2. Then I1 is coming to this point, again it will split as I3 and IG. I3 will goes to through the Q resistance, Ig will goes to the galvanometer. That galvanometer is a device that is used to measure the small currents. right? It can measure the small currents. And now this side I3 will goes, and this side Ig is coming, this I2 and Ig is combined, and it will go as I4. Now let us see. At point B, entering current is I1 and the leaving current is this side I3 and this side Ig. We write I3 plus Ig, right? This is equation 1. And at point D also we can apply the Kirchhoff's first law. At point D, entering current is what? I2 current is coming this side, Ig is coming this side, right? I2 and Ig. Though two are combining, then what we write? I2 plus Ig is equal to what we write? This is the entering current, and what is the leaving current at junction D? Right, according to Kirchhoff's first law, entering current equal to leaving current, right? How much current leaves it here? Only I4 leaves. That means I2 plus Ig is equal to, we write I4. This is equation 2. Next, Kirchhoff's second law also we will apply, right? Now apply Kirchhoff's second law, right? That is loop law or junction law. Okay, and first for the loop, one loop I will select A, B, D, A. Okay, I am selecting a loop, that is, loop means closed path. One, you start from A and again come to the A. The loop I am selecting as A, B, D, A, right? A, B, D, A. And for this loop, then we will apply the Kirchhoff's second law. What is our Kirchhoff's second law? Algebraic sum of potential differences in a closed path is equal to 0. Closed circuit equal to 0. Now sum of potential differences we have to write. A to B we are going. Next A to B we are going. Next B to D we are going. Next D to A we are going. Now when you will go, potential differences sum we have to write in the closed path. A to B, next B to D, next B to A. Then how to write the algebraic sum of potential differences in a closed circuit? For that, first we are going from A to B, then in the direction of current you are going. Remember that if you go in the direction of the current, then potential difference is IR, but you have to take negative. If you go opposite the direction of the current, right, then you have to take as positive. And for this already we discussed, and that you refer the previous lecture, that is Kirchhoff laws. In that sign convention will be there. Okay, right, let us go. You are going in the direction of the current. A to B we are going first. A to B in the direction of the current. Then potential difference formula is what? According to Ohm's law, minus IR, right? Minus potential difference. Okay, in the direction of the current. If you go, then potential difference you have to take negative. Potential difference is how much? Current into resistance IR, I1P, but you have to take minus. Next, A to B completed. Next, B to D I am traveling. Again in the direction of the current we are going. When you will go in the direction of the current, we have to take minus. Then what is the potential drop across this galvanometer, right? B to D you are going. Then that is current into resistance. Current is Ig. Galvanometer resistance is capital G. Next, D to A to B completed. B to D completed. Next, D to A. D to A I am going. Opposite direction of the current. I am going this side, but current this side. That means then you have to take potential difference as positive, that is plus I2R. Okay, now again we reached the A to B in the direction of the current, negative. B to D in the direction of the current, negative. D to A, opposite direction of the current I am going, because I am going from D to A, but the current is from A to D. That's why you have to take positive. This sum is equal to what? 0, right? This is equation 3. Next, the same we can apply for other loop. For loop, one more loop is that I will select this side loop, B, C, D, B. I will select the loop B, C, B, C, D, B. B, C, D, B. Yes, we can apply the same Kirchhoff's second law. Then that is, what is our Kirchhoff's second law? Algebraic sum of potential differences equal to 0, right? Algebraic sum of potential difference. All potential differences we have to add, that we have to equate to 0. First you have to travel B to C, next C to D, D to B. First B to C, in the direction of the current you are going. That's why you have to take minus, right? Minus potential difference is what? Current into resistance. We call IR. Current is I3, resistance is Q. Current I3, resistance Q. IR, I is I3, R is Q. Next C to D I am going. B to C completed, next C to D. C to D is opposite direction of the current, then you have to take positive, right? If you go in the direction of the current, negative. Opposite direction of the current, positive. What is the potential difference? C to D potential difference. Current into resistance. Current is I4 at here. What is the resistance at here? S, right? Next, finally I am traveling from D to B. B, C, D, B loop, right? Then again D to B I am traveling, opposite direction of the current, right? D to B I am going, but the current going right downward. Already current distribution we did first. Okay, then let us see. Plus I G, here potential difference is positive, we have to take because we are going D to B, that is opposite direction of the current. IGG, that is equal to 0, right? Current into resistance. Here current is IG, resistance is G. This is equation 4, right? Like this, by applying Kirchhoff first law and second law, we got the 4 equations. Now what you have to do? Now you have to do one thing, that by adjusting the values of P, Q, R and S, make the current through galvanometer as 0, right? That means what is the current through galvanometer? IG 0. Okay, then the bridge, which bridge it is? Wheatstone bridge. The Wheatstone bridge is nothing but arrangement of 4 resistors, right? Then the bridge is said to be balanced. What is the balancing condition? Current should be 0, right? Okay. Now by adjusting the values of P, Q, R and S, make the current through the galvanometer as 0. Adjust the P, Q, R, S and then make the current through galvanometer as 0. Now this condition, IG is equal to 0, is substituted in equation 1, 2, 3 and 4. In all the above equations, this condition you substitute. Then what you will get? When you substitute the IG is equal to 0, automatically you have to get the P by Q equal to R by S. If you will get P by Q equal to R by S, then balancing condition is proved. This is very simple. And take the screenshot and note all the points. This is very important topic, right? And now let us see. If you know Kirchhoff laws, then you will get this answer. Okay, I am going to rub it. What you will get in the equation 1, if you substitute the Ig as 0, what you are doing it here, by adjusting the values of P, Q and R, S, you are making the current through the galvanometer as 0. Then that condition, current through the galvanometer as 0, Ig 0, that you are substituting in all the equations, right? What are the equations? Equations 1, 2 and 3, all these equations. Okay, let us see. If you substitute in equation 1, what you will get? From equation 1, yes, what I am doing it here, Ig substituting as 0, current through galvanometer as 0. This is 0, means you will get I1 is equal to I3. I1 is equal to I3 plus Ig is 0, right? This is equation 1, 2, 3, 4 completed. This is equation 5. Next, from equation 2, what you will get? Ig I substituting as 0, then I2 is equal to I2 plus 0 is I2. Okay, this is 0. Then I2 is equal to I4 we will get. I2 is equal to I4. This is equation 6. Next, I am going to substitute in equation 3 also. Then from equation 3, what you will get? From equation 3, here Ig we are substituting 0. Then this term totally becomes 0. Right? Then you will get minus I1p. This term is 0. Okay, because Ig is 0 plus I2R we will get is equal to 0. Right? Here this term will become 0 because Ig is 0. And then from this we will write minus I1p we will take to right side. Then I2R is equal to I1p, or we write I1p is equal to I2R. This is equation 7. Next, from equation 4, what you will get? You also substitute the condition in the equation 4. That equation 4 is this one. Minus I3q plus I4s and plus Ig is 0. Then this condition 0 you will substitute is equal to 0. Right? This Ig is 0 means this term totally 0. Then you will get this minus I3q taken to right side. Then I4s is equal to I3q you will get. Right? Now this I3q we write this side and I4s we write that side. This is equation 8. Now equation 7 by 8 we divide the equation 7 with 8. Then what you will get? I1p by I3q is equal to I2R by I4s. Right? But from equation 5 and 6, from equation 5 and 6, I1 and I3 are equal. That's why this and this will cancel. And I2 and I4 also equal. This and this will cancel. These are cancelled from where? From equation 5 and equation 6. Next, what you will get? Final equation. The final equation we will get the answer, that is P by Q is equal to R by S. That means if current through the galvanometer is 0, then what happens? If Ig is equal to 0, then P by Q is equal to R by S. Its proof is completed. Right? This is about Wheatstone bridge. Okay? If current through the galvanometer is 0, then P by Q equal to R by S. Right? Okay, this is very important topic and listen very carefully. And now let us discuss some applications of Wheatstone bridge. For that, let us see. I am going to rub this total, and for that, firstly you have to take one screenshot of this one, and then after that note all the points. Okay, I am going to rub totally by pressing the pause button. Okay, now I am going to continue. Some important points regarding Wheatstone bridge I am going to explain. Okay, note these important points. And when the position in the galvanometer, already you know balancing condition, right? When the current through galvanometer is 0, then P by Q equal to R by S. The ratio of these two resistances equal to these two resistances. P, Q, R, S are the resistances, and G is also resistance of the galvanometer. This is the galvanometer and its resistance, right? And if the current through the galvanometer is 0, current through this line is 0, then P by Q equal to R by S, means the ratio of these two resistances equal to these two resistances. By using this formula, if you know Q, R, S, you can find out P. If you know P, Q, R, you can find out S. That means Out of 4 resistances, if you don't know one resistance, okay, that resistance we can find out by substituting the values of other resistances. Right, look at here, one point I am giving that is important. When the position of galvanometer and battery are interchanged, look at here, in the diagrams are interchanged. This is previously we derived, right? Galvanometer is at here and battery is at here. Now we interchanged, right? The battery replaced with the galvanometer and the galvanometer replaced with the battery. They are interchanged their position. If you interchange the positions of the galvanometer and battery, then it will not affect the balancing condition. That means the balancing condition will be same in the both diagrams. Okay, this is in this diagram the balancing condition. When the current through galvanometer is 0, then P by Q equal to R by S. This is the current through galvanometer, right? Current through galvanometer is this one. When the current through the galvanometer is 0, then P by Q equal to R by S. When the current through galvanometer is 0, then P by Q equal to R by S. And now I am going to explain the other forms of Wheatstone bridge. Wheatstone bridge not only in this shape, there are some other shapes also there for the Wheatstone bridge. Let us see one shape. This is general shape, and other shape I will give. This is, for example, 4 resistors. Okay, this is 1, 2, and 3. This is the 3 resistors, and for example, if they are connected like this, actually I said this example previously, and this is actually what we says. This is actually we say that this is a parallel combination. Okay, due to these wires. In previous lecture I explained the other form of the Wheatstone bridge I will tell, and here we will keep one resistance, right, and here also we will keep one resistance, and this is P and this is Q and this is R and this is S. This is the resistance of the galvanometer, right? This is capital G, right? This is other form. This is equivalent to this. Okay, 2 are equal. How they are equal? Let us draw this diagram like this. Okay, you start from here. This point is we can consider as A, and this point we can consider as B. Now you start from A like this, and it goes to P, right? It goes to P like this. Then after that, the P end is connected to Q. The P end is connected to Q, right? Here, look at here, Q connected. Okay, the Q end goes to B, right? This point is B, and this point is A, right? And 2 are equal. This point is B, and this point is A, and here also this is equal to this, right? And this point I am taking A, and this point I am taking as B. Okay, look at here, once again I will explain. And you start from A, okay, it goes to P, then it goes to P, right? And then after that, P end is connected to Q, right? The P end is connected. This is the P end connected to Q, P end connected to Q, and the Q end one end is connected to B, and the Q one other end connected to S. The Q other end is connected to S. The S other end is connected to R. S other end is connected to R, right? Okay, R, and R other end is connected to A, right? And where the P and Q are meet with each other, from there galvanometer starts. Here, look at here, P and Q are meeting at this point. From there galvanometer will starts, and that will goes to the other end of the galvanometer, goes to a point where R and S will meet. And look at here, this is the R and S. They will meet at this point. R is coming like this, S is coming like this, and the other end goes to this side. This is 2 are equivalent diagrams, and other equivalent diagram I will tell. Okay, the other equivalent diagram is, again we have to draw the 3 resistors, and this is A and this is B. Okay, instead of drawing above, we have to draw below, right? Okay, and this is P and this is Q. Okay, this is R and this is S and this is G. Okay, all are equal. This diagram is equal. And one more other form of Wheatstone bridge is just like this. It will be there. This is one triangle shape we can draw. This is the galvanometer. This is P. Okay, let us see how to draw other form of Wheatstone bridge. In this, first we have to draw in the shape of triangle like this, other form of Wheatstone bridge. Here we have to take one resistance, that is P. In the competitive exams they will ask this type of questions, and this is A. This is A point and this is B point, and here one resistance, that is Q, and the next here we write R, and this is S. Okay, this is one more form of Wheatstone bridge. Okay, P, Q, R, S. In all the cases we can write what we write. When the current through galvanometer is 0, then what we write? P by Q is equal to, we write R by S. If the current through galvanometer is 0, then we write P by Q equal R by S. This condition is obeyed for all. What is the condition? If the current through the galvanometer is 0, then P by Q equal to R by S. These are the other forms of Wheatstone bridge. What is the use of these forms? I drawn the different forms. Is there any use with this? Right? Yes, there is some use is there, and we can find out the effective resistance by using these other forms very easily. Okay, let us see. I wrote this condition at here, but that condition is not appearing, I think. I will write here the condition. If the current through galvanometer is 0, right? If the current through galvanometer is 0, then what do we write? P by Q is equal to, we write R by S. Now let us see. I will continue. If anybody asks to find out the effective resistance between the A and B in all these cases, right? What is the effective resistance between all the above cases? I will find out very easily. Right? For example, they give the question like this: if the current through the galvanometer is 0, find the effective resistance between the A and B. This is our question. In any diagram they will give. Right? After that, what they will tell? If the current through the galvanometer is 0, then find the effective resistance between A and B. These are all equal. This is equal to this, this is equal to this, this is equal to this. All are the different shapes, right? Different shapes of Wheatstone bridge. Wheatstone bridge basically one shape, this one, but that will be modified into different shapes, but all are equivalent diagrams. Okay? All are equivalent diagrams. Now let us see how to find out the effective resistance. In above figures, in any above figure, right? In above figures, if current through galvanometer is 0, current through galvanometer is 0, then find effective resistance. Between points A and B. This is our one question, let us consider. In all the figures, what we have to do, right? What they gave in the question, okay? In all these figures, if the current through the galvanometer is 0, what we write the condition? If the current through galvanometer is 0, if Ig is equal to 0, current through galvanometer is 0, then we remove the galvanometer because the current not passes through the galvanometer. Then we remove galvanometer, right? We remove galvanometer from circuit and we remove galvanometer from the circuit. And let us redraw the diagram. Okay, let us redraw the diagram. Then how you will get after removing the galvanometer. Okay, if Ig is equal to 0, then we remove the Ig 0, current through galvanometer is 0, then we can remove this part because it is not passing, current is not passing through it. If they remove this part, then also current not passes between these 2 points. Okay, and if we not remove, also here the condition they gave, the current through galvanometer is 0. If the current through galvanometer is 0 means whether this part is there or not there, whether the galvanometer is there or not there, it is not matter, that's why we can remove. Okay, if you remove, then we can redraw the diagram. This is A, this is P, and this is Q, and this is R, and this is S. Like this we will get the diagram. Okay, or otherwise we can draw like this also. For this also we can draw that we can remove the galvanometer. This part we have to remove, this part we have to remove, right? Okay, then if you redraw the diagram, then you will get like this. This is P and this is Q and this is R, this is S, and now this is A, B, equivalent diagram. This is A and this is B. In every diagram we can do the same thing. Here we remove this G, we redraw the diagram. Here we remove the G, redraw the diagram. In every case directly we can find out the effective resistance. Okay, right? How we do here? Then effective resistance between the A and B, if the current through galvanometer is 0, then it was very simple to find out the effective resistance between A and B. Like this they will give the question. They will ask to find out the effective resistance between the A and B. If the current through galvanometer is 0, then you remove this G part, then it was very easy because P, Q are in series, right? Okay, P, Q, this Q is there. Then the current does not divide set here, the same current passes. Then these two are in series. What is the effective resistance in series? P plus Q, right? That means, and these R and S also in series, and their effective resistance are in parallel combination. P plus Q and R plus R in parallel combination. Then what you will get the effective resistance between the A and B? Right? What is the effective resistance? Here we draw the diagram like this. This P and Q are in series, right? This R and S are in series, and the effective resistance of P and Q and R and S are in parallel combination. Then very easily we will get the diagram. That this diagram I will redraw again. PQR and effective resistance is PQ effective resistance is we write as P plus Q, and RS effective resistance is R plus S. Right? This is A and this is B. Now what is the effective resistance between the A and B? Effective resistance between the A and B is, this is P plus Q and R plus S. These two are in series, P plus Q. These two are in series, R plus S. Their effective resistance, what we have to do? Right? R1 R2 by R1 plus R2 in parallel combination formula. Right? R1 R2. R1 R2 by R1 plus R2. That means we will get P plus Q into R plus S by P plus Q plus R plus S. Okay, this formula is from parallel combination of resistance, right? R1, this is you take R1, this you take as R2. In parallel combination formula is what? R1 R2 by R1 plus R2. This we have to multiply plus by this 2 we have to add, right? P plus Q plus R plus S. By using this formula, right, we can easily find out the effect resistance between the A and B in this, any diagram, for any diagram, for easily we can find out the effect resistance if they will give the condition as current through galvanometer as 0, right? And this is the method to find out the effect resistance. Here also the same thing, they will give the diagram like this and they will ask to find out the effective resistance. Okay, and now let us go for another point, the important points I am telling regarding the Wheatstone bridge. The third point I am going to explain, that is, this is not only applicable for the resistors, it is also, the Wheatstone bridge principle is also applicable for the capacitors, not only resistors, it is also applicable for the capacitors. Then how we will apply for the capacitors? For example, the third point I am going to tell, this is very important, right? The Wheatstone bridge principle, Wheatstone bridge, balancing condition is also applicable for capacitors. Then how it is applicable for the capacitors, let us see. And here I will take the one capacitance C1, next C2, next C3, next C4, and here one more capacitor I will take, that is C5, right? And their combination is like this there, and this point is connected to A and this point is B. Here I will connect this combination to some battery, right, like this. Okay, and now, or otherwise we can draw this diagram like this, Wheatstone bridge. This diagram we can also draw like this, that is, first three capacitors we will take like this. This point is, we will take A, and this point we will take as B. This point is A, this is similar, right? This point is B. C1, C2, C3, C4, C5. Okay, and this diagram, in this diagram, if we write the equation like this, we can write the condition like this. Here instead of resistors, here resistors is there. Here C1, C2, C3, C4 resistors P, Q, R, S. Instead of P, Q, R, S, here C1, C2, C3, C4 are there. Instead of galvanometer, C5 is there. If current through C5 is 0, if current through C5 is 0, then we write balancing condition. That is, if current through C5 is 0 means we write galvanometer Ig is 0. Then we write as ratio of resistances P by Q equal to R by S. But instead of P by Q we write the capacitance. C1 by C2 is equal to, we write as C3 by C4. Okay, if the current through the C5 is 0, if the, instead of current capacitor here galvanometer is there, if the instead of galvanometer here capacitor is there, if the current through galvanometer is 0, here current through capacitor is 0, capacitor C5 is 0, then the ratio of the capacitance of these two, C1 by C2 is equal to C3 by C4. And the effect resistance also we can find out. Current through C5 is 0 means we can remove this part, and these two are in series and these two are in series, their effect resistance is in parallel combination. Easily we can find out, right? And this is some other forms of Wheatstone bridge, and I will give some two problems based on this, and I will close today's topic, and I will rub the every point, and you note, take the screenshot and note it. Okay. Okay, look at here. This is the last problem. This is similar to the Wheatstone bridge, right? Other form of Wheatstone bridge. This is P and this is Q and this is R and this is S and this is Z, galvanometer. What they gave in the question, find the effect resistance between A and B. Between A and B effect resistance we have to calculate, right? And after that we have to find out the current drawn from the battery. How to find out the effect resistance already you know. If current through galvanometer is 0, we can remove this part. But when the current through the galvanometer is 0, right, we know the balancing condition, right? The balancing condition is what? Balancing condition, if current through galvanometer is 0, then P by Q equal to R by S. But if you P by Q equal to R by S, then current through galvanometer is 0. It's reverse also, it is truth. Then current through galvanometer is 0. If Ig 0, then P by Q equal to R by S. If P by Q equal to R by S, then Ig 0. Current through galvanometer is 0. Let us check whether P by Q equal to R by S condition obeyed or not. In P by Q equal to R by S, let us see, P is 1, Q is 2, R by S, R is 2, S is 4, then what you will get here? 1 by 2 is equal to 1 by 2 we are getting, right? That means P by Q equal to R by S. That means the current through galvanometer is 0. This part we can remove, right? This part we can remove. When you remove that part, what you will get? Yes, easily we will get this point A, and this is P, 1 ohm, and the next, not like this. What we have to do here? P by Q equal to R by S. Then the current through this part is 0. Right? P by Q is 1 by 2, R by S is 2 by 4. Then we can remove this part because this condition is obeyed. When the P by Q equal to R by S, then the current through galvanometer is 0. Or current through galvanometer is 0 means P by Q equal to R by S. Then we can remove this part. When you remove this part, right, we can draw the equivalent diagram now. This is P is 1 ohm. Next this is Q, 2 ohm. And the next, this is connected to B and this is A. On the other side, this is R, R is 2 ohm. And next, this is S. What is our S? S is 4 ohm. Okay, very simple. Just removing this part, rub it, remove this part. Why we are removing this part? Because P by Q equal to R by S, then current through galvanometer is 0, current through this part is 0. When the current through this part is 0, this part is removed. When this part removed, this part you will get like this. Then what is the effect resistance? These two are in series, right? Then what is the formula for the effect resistance? Direct also we can write P plus Q into R plus S by P plus Q plus R plus S, right? When you substitute this one, 1 plus 2, 3, P plus Q, 1 plus 2, 3, 3 into, here 2 plus 4, 6, 3 into 6 by 3 plus 6 we will get, okay? You simplify this and you will get 18 by 9, effect resistance we are getting as 2 ohms, okay? Then they are asking the current drawn from the battery. Current is equal to voltage by effective resistance, total resistance, voltage by R effective resistance. What is the voltage at here? 4 volts. Effect resistance is what at here? What you got the effect resistance? 2. What is the current? 2 amperes. Simple solution. If you will get the doubt, you can ask me later. And now look at here, one question I am giving. Find the value of capital R in the figure when there is no current in the 15 ohm. Through this 15 ohm there is no current. That means 15 ohm we can take as galvanometer. When the galvanometer current through is 0, when the current through galvanometer is 0, then we write P by Q equal to R by S. 20 by 10 equal to 40 by R. By that we can find out the value of capital R. Okay. then we are asking to find out the value of Kepler. In this figure, if the current through 15 ohm is 0, then find the value of Kepler. P, Q, R, S. The ratio of these sides equal to these sides. That means 20 by 10 equal to 40 by R we write. P, Q, R, S. When current through this is 0, then P by Q equal to R by S. Here current through this is already 0 they give. Then you can find out and do it immediately and send me in the comment. Okay. Thank you for watching my lectures. Till now, if you not subscribe, kindly subscribe my channel and share to your friends, those who are in the 12th class. Thank you. We will meet in the next lecture.